Welcome to Learn Math with J. Today, our topic is going to be based on the equation of a tangent to a curve at a point. So, equation of a tangent and normal to a curve. All right. So, tangents and normals, they are the lines that are associated with what? Curves. Curves such as circles, can talk about parabola, we can talk about ellipse, we can talk about hyperbola. Yes. So this tangent and normal, they are associated with what? This type of what? This curves. And a tangent is a line. A tangent is a line touching a curve at a distinct point. So let's say I have a circle, then a line which is touching this circle at a distinct point called the point of tangency. So this line is what? A tangent to this what? Curve. Right. And each of the points on the curve has what? A tangent. Right. So you have a point here, another point here, another point here, another point here. A line which is touching this particular point, only this point is a tangent to what? The curve. Then we talk about the normal too. The normal is a line perpendicular to the tangent at the point of contact. So at this point, you can have a line which is perpendicular to what? The tangent here. So this line becomes what? The normal. And this is the tangent. So normal is what? Perpendicular to what? The tangent of a curve. Right. The first derivative evaluated at a point gives a gradient of a tangent at that point. So when you are given, let's say y equals 2x squared plus 9, the first derivative, the y, the x, is equal to 4x. This here, when evaluated at a point, let's say 2, 5, this is going to give us 4 times 2. This is what? 8. When evaluated at this point, this number here gives the gradient of the tangent. Now you see that we said that this normal here is perpendicular to what? The tangent. So what happens to the gradient of what? The perpendicular lines, right? So the negative reciprocal of the gradient of the tangent will give you what? The gradient of what? The normal. So it means that from here, the gradient of the normal will be what? Negative 1 on what? 8. Right. So this is the normal is perpendicular to what? The tangent at the point of what? Contact, or the point of tangency. Right. So now with the gradient, since we are talking about lines, so we are talking about the gradient. Now we have a gradient. After getting the gradient, we can easily find the equation of that particular tangent. So the tangent is a line, right? So how do we find the equation of a given line? So we use y minus y1 equals m x minus what? X1. Now this here means this m here is the gradient of that particular line. Then we have y1, y2. That will form the point that is being given at that particular point, right? So it means that if this is the equation of the tangent, then what will be the equation of the normal? That will be y minus y1 equals negative 1 on m x minus 1 x1. Yes. So you see that the gradient here is the negative reciprocal of this. So they are perpendicular to each other. So that is that. Okay. So what happens next? So when you to find the equation of that particular tangent after getting the gradient, then you use together with the point to find the equation. So let's take an example here. Find the equation of the tangent and normal to the curve y equals 3 plus 2x minus x squared at 2, 3. Okay, so we have been given this, and we said that to find the equation, we need to get our gradient, right? So let's look at how to find the gradient. And we said that the first derivative being evaluated at the point here will give us what? The gradient of the tangent. So let's talk about the gradient of the tangent first. Of the tangent. So let's see. When we are to differentiate this, we have y equals 3 plus 2x minus x squared. So differentiating with respect to x, this is going to give us what? 2 minus what? 2x. Now at the point 2, 3, what is the x coordinate? Is what? 2. Then we can substitute that into it. So we have 2 minus 2 times what? 2. And this is going to give us 2 minus 4, of which we are going to get negative 2. All right. That is the gradient of what? The tangent, which is a negative 2. Now, we are to find the equation. So we have y minus y1 equals m, x minus what? x1. Now from here, y minus y1 from the point, we have the y coordinate being what? 3. Then our gradient is what? Negative 2. Then we have x minus the s coordinate is what? 2. Right. Then we expand this, we simplify this. So let's see, y minus 3 equal to what? Negative 2x plus 4. Okay, so we can write this in this form: 2x plus y minus 3 minus 4 equals what? 0, which is the same as 2x plus y minus 7 equal to what? 0. And this is the equation of the tangent. Right. Now to the equation. The question is asking us to find the equation of the tangent and the normal. Now we know we said that to find the equation of the normal, that will be y minus y1 equal to negative 1 on m x minus what? x1. Now from here, we have the gradient of the tangent to be negative 2. So it means that the gradient of the normal will be equal to negative 1 on negative, right, 2. So you have as what? 1 on what? 2. And that is the gradient of the normal, right? Now we know the gradient of the normal to be 1 over 2. So our equation will be y minus, what is the point? The point was 2, 3, right? So you have y minus 3 equal to 1 on 2 times x minus what? 2. Now we have a fraction here. We can multiply through to get rid of the fraction. So we can get 2y minus 6 equal to what? 1 times x minus 2. This is going to give us 2y minus 6 equal to what? X minus what? 2. Now we can rewrite this as x minus 2y minus 2 plus 6 equal to what? 0. This one will give us x minus 2y plus what? 4 equal to what? 0. Right. And this is the equation of the normal. Yes. Let's take another example on this and see how we would solve this. Solve it. Okay, so it means that when you are given the question to find the equation of a tangent and normal, the first derivative will give what? So the first derivative evaluated at the point given will give you the gradient of the tangent. Then the negative reciprocal of that will give you the gradient of what? The normal. Then you can use that together with the point to find the equations of both the normal and the tangent. All right. So that is that. Okay. So let's take another example on that. So we have find the equation of a tangent to the curve y equals 2x plus 3 or exponent 3 at negative 1, 1. Right. So how do we do this? We have to find the equation of the tangent to that curve. So let's see. The first derivative will give us the gradient of the tangent. So our dy dx will be equal to this one. We can use the appropriate rule. We can decide to use the the chain rule, right, to do this. So straightforward, you can also use it. So by normal differentiation, this is going to be 3 times 2x plus 3 exponent what? 2, right? Then you differentiate the one in the bracket. This is going to give us what? 2. And the result will be what? 6 2x plus 3 exponent what? 2, right? So now at the point negative 1, 1. So our x coordinate is what? Negative 1. So this is going to give us what? Let's see, we have 6, 2 times negative 1 plus 3 exponent what? 2. Then we have 6 negative 2 plus 3 exponent what? 2. Then we have 6. This is going to give us 1 squared. So our answer is 6. And that is the gradient of what? The tangent. Now we know the gradient of the tangent. How do we find the gradient? The equation. So now the equation of a tangent. Equation of a tangent. Okay. So we have y minus y1 equal to m, x minus what? x1. So our point given was negative 1, 1. So we have y minus 1 equal to 6 times x minus negative 1 already there. So we have plus 1. So y minus 1 equal to 6x plus 6. Right. And this is going to give us what? You have y minus 6x minus 1 minus 6 equal to what? 0. So you have y minus 6x minus 7 equal to what? 0. So you can rewrite this. Okay, so that is that. So that's the equation of the tangent. Okay, so that's that. Thank you for watching, and don't forget to subscribe for more videos.